Okay, this is number 20. So this time we're gonna be dealing with this crazy looking trig functions. And first of all, let's spot this cosine parentheses pi over 2 minus x. We know that this is basically sine x. Okay, we know that this secant x is 1 over cosine x. Okay, so I'm gonna multiply. Okay, I'm gonna multiply the 1 over cosine x to sine x. That's gonna give me sine x over cosine x. Okay, we're gonna add that to sine x. Okay, so because since I don't have enough space, so I'm gonna tell you that I'm gonna try to change this sine x to the same denominator as cosine x. So the way I do it is I multiply by cosine x over cosine x. So that is going to give me sine x over here. Okay, on the bottom, we know that is 1 plus secant x. So that's going to be 1 over cosine x. And we're going to try to change the 1 in the with the denominator equals to cosine x. So I'm going to use cosine x over cosine x and be able to add them up. Okay, so the next thing I want to do is I'm going to add the numerators up. So I have sine x plus sine x cosine x, everything over. Denominator doesn't change when you're adding cosine x. Okay, and then I'm going to divide it by cosine x plus 1 over cosine. And then I'm going to change this to a multiplication. Okay, so which means that if I divide and then change it to multiplication, that means the fraction is going to flip. Okay, so I'm gonna rewrite this as multiply by cosine x over cosine x plus 1. Okay, we'll be able to cancel these out. We see the cosine x over here, cosine x over here. Okay, and then what I'm going to do is I'm going to look at the common factor of these two terms, and I realize it's going to be sine x and sine x. Okay, so I'm going to factor out the sine x on these two terms. So what's going to happen is that I factor out the sine x, and then that'll left me with 1 plus cosine x. Okay, and you're going to see that you'll be able to cancel these out. So when you simplify this whole craziness, it's actually going to just equal to sine x. Okay, number 24. Start from number 24. I want you guys to prove that left side is equal to right side. Okay, you're going to play around with it. Just think of it as a game. Okay, let's try this. So first of all, tangent, and then cosecant, and then cosine. Okay, how do I play with this so I can equal to 1? So we know that cosecant is 1 over sine theta, and then you multiply by cosine theta, and then we're going to have to change the tangent to sine theta over cosine theta. Okay, so sine theta over cosine theta multiply across cosine theta over sine theta. when you multiply this, you see that you'll be able to cancel stuff out, right? Okay, so this is going to equal to 1, equal to 1. Number 26, we know that this is going to equal to cosine x. Okay, we know that tangent is sine x over cosine x. Okay, see if this is really going to equal to sine x. This one is an easy one because you can just go ahead and cancel out the cosine x and find out sine x does equal to sine x. Look at number 28. Okay, so before I talk about number 28, I do want to talk about um, that how I got from x squared plus y squared equal to 1 to cosine squared theta plus sine squared theta equal to 1. Okay, because earlier on the previous preview video, I told you guys that every time when you see x is basically cosine, okay, theta, and then if you see y is basically saying sine theta, okay. But the thing is that there is a square on x and y, right? So you have to square the cosine theta and the square on the sine theta, okay? So here is the property. So whenever you see this cosine theta square, you can actually write it as cosine square theta. If it's a sine theta square, like this, you can write it as sine square theta. Okay, they're actually the same expression. Okay, so now I'm gonna tell you guys why this is important for this problem. Okay, I'm gonna go ahead and do this problem. Okay, first of all, if you guys look at the property, so let's see. So the property of this one is negative angle identity. So for the sine square of negative x, this is basically saying negative sine square x. Okay, but we know that you can rewrite this as put a parentheses and put a square on top. Okay, over tangent. Okay, so tangent, I'm actually gonna, every time when I see tangent, I have an instinct of just put it as sine and cosine. Okay, so tangent square is gonna be sine square x over cosine square x. Okay, see that's gonna equal to cosine square x. Okay, go ahead and find out. So we know that this is basically saying negative sine x times negative sine x. So this is going to equal to positive, okay? Positive sine x. I mean sine square x. Okay, so we can just write sine square x over, we don't have to do that anymore. Okay, we're gonna divide it by sine square x over cosine square x and see if that equals to cosine square x. Okay, and I told you guys earlier, whenever you guys see division, you can change the multiplication, but make sure that you guys flip the fraction. Okay, so multiply by cosine square x over sine square x. Okay, cancel out the sine square x. So you have cosine square x equal to cosine square x. So they are equal. Okay, last one. This craziness. Let's see how this works. So we have cosine negative x. If you guys look at the negative angle identity, this is basically just cosine x. Okay, so rewrite the 1 minus cosine x. Okay, let's write the sine x on top. Let's see if that really equal to cosecant x plus cotangent x. Okay, so this is what you do. Sometimes when on the left side you don't know what to do with it, you can actually use the help from the right hand side. So instead of writing the cosecant x and plus cotangent x, I'm actually gonna just write that in the reciprocal form. So 1 over sine x plus cotangent is adjacent, well, cosine over sine. Okay, let's see if they're going to equal to each other in this case. Okay, so let's add them up. 1 plus cosine x over sine x. Okay, on the left hand side is going to be sine x over 1 minus cosine x. Okay, it looks like, how can these be even close to equal to each other? Okay, it looks kind of weird, but I'm gonna tell you why. So this is what you do. You guys are gonna use something called the um, 1 plus cosine x um, and multiplying the numerator and denominator. This is called the conjugate, right? You guys remember that this is called a conjugate. Okay, so go ahead and just multiply this. So you should be able to get that on the numerator side is sine times 1. So that's sine x. Sine times cosine x is going to be sine x plus, oops, sorry, sine x cosine x over, on the bottom is going to be 1 minus cosine square x. Okay, so bringing back the old memory, the old G identity, sine square x plus cosine square x equal to 1. Okay, so if you subtract cosine square x on both sides, you should get sine square x equal to 1 minus cosine square x. And so, which means that this is going to equal to sine square x. Okay, there we go. Change that. Change that to sine square x. Okay, now I'm going to factor out the common factor of both terms, which is sine x. So I'm going to rewrite the top. So it's going to be sine x 1 plus cosine x. Okay, is that going to equal to the right hand side, the right expression? Okay, if you look at it, yes, it will. Oops. So sine x cancel with the sine x from sine square x. So this is going to left you with sine x on the bottom. Okay, and now if you look at it, they are equal to each other. Okay, that's it for the for all the questions I'm going over from chapter 9.7. I'm done. Okay, I think the it's gonna take some experience to do these problems, but try your best. Okay, have a good one.